to start off the talk with some audience engagement, because I think that's a good way to start. Who here has been running Aurora and Mesos, well, I guess Aurora or Mesos in production for longer than 6 months? Wow, that's impressive. Longer than a year? Okay, yeah, if you're from Twitter, drop your hand, I guess. Wow, awesome. And longer than a year and a half, 2 years? 2 years and 2 years, 6 months? All right, wow, that's a shame. Well, I guess Mesos was, but not Aurora. Wow, okay, so this is actually super exciting to see so many people out here. When we were first starting to think about open sourcing Aurora, it was sort of like the missing piece, I think, to what you'd really need to actually take your data center, which is running discrete machines, and whether you're using Chef or Puppet, and you're sort of used to having an ops team, which is managing manifests, and actually transitioning to something that you're actually empowering your developers and your engineers to launch these services across the data center, and you don't care about which machines they're on or where rack maintenance is happening. So I think once Aurora came out, it's really starting to enable this new type of application, and I think it's really changing the way that Mesos is being seen and used, which is pretty exciting. Pardon me. Sort of like Steve was saying, if you guys have any questions, please feel free to jump in. I'm really going to sort of break this talk up into 3 different pieces. So the first one, this is all about operating a Mesos and Aurora cluster. So the first piece is, how would you actually set this up? What does it look like to build all of these components? There's a lot of moving pieces. What does it look like to actually deploy this out into production? I'm obviously heavily biased, and so I'm going to sort of describe the way that Twitter does these things, but I'm hoping that there'll be some lessons even if you're not necessarily operating at Twitter scale. Once you actually do have all of these components up and running and you're able to send jobs to the scheduler, what does it look like to actually operate this thing? It turns out a lot of our time, once we got these pieces running, was dealing with user support. So we sort of became, obviously, because we're Aurora and Mesos teams, we're the experts on these systems. And so all of our users that are then launching their jobs and their services on top of our platform have tons of questions. I imagine they're very similar to the questions you guys have. Well, how do I actually build a Java app, and how do I launch it? How do I do service discovery? Things like that. So I think it's really critical that anytime you're talking about actually running these in production, anybody that's on the ops team or an SRE or DevOps is an expert in these systems, and you really need to know the ins and outs of this. And that includes knowing how the code is written, what's the process for getting commits in, stuff like that. Lastly, we're going to talk about some of the not so good things. So this is actually some of the issues and incidents we've had and some of the things we've needed to do to fix things. So I assume that'll be the fun part. Maybe fun for you guys, not so fun for me, unfortunately. Yeah, overall, we're really just going to be talking about the cloud and hopefully explaining what this all is. I only have a few memes, I promise. So contrary to what I think your typical SRE is going to say, I actually think that Aurora and Mesos are great, not just for the teams that are building and writing Aurora and Mesos itself, but even as an operator. I'm actually really impressed and sort of surprised at how easy it is for me to get things done, even if it's just routine kernel maintenance or rebooting hosts or working with our net engineering team. Sort of the abstractions that it leads the application engineers to build really enable me as an operator to move through the cluster and not be bogged down in details. So it basically means I don't need to spend all my day babysitting a couple servers. Instead, I can just use our maintenance API, send them off for maintenance, and then go back to writing some code and building more automation, which is really exciting. So one thing that I wanted to point out is that what I think really separates Aurora from a lot of the other frameworks that are running on top of Mesos is that Aurora is proven and battle-tested. It's been in production for over 2.5 years at Twitter, and it's essentially what we are depending our entire enterprise upon to be reliable and stable. It's one of the few Tier 0 services that we run at Twitter, and there are a few failure modes which if we don't protect against them and if we don't invest correctly in these systems, then they're going to take the entire site down. And so being SRE for Aurora and Mesos not only means that we need to sort of take what's currently running and make sure that it's running well and well-tuned, but also that we're paying attention to what's the current design plans, where are the next steps going, and how are we going to help shape this infrastructure to actually grow and become more reliable even as we're adding more features and more functionality for our users. So this is the most important piece because every time there's an issue, I'm stuck in a postmortem and I need to go into a huge amount of detail, multiple pages in a Google Doc, tons of links, tons of tickets. So ideally, I do a little bit of work ahead of time to make sure the design is good, and then I don't need to explain to our VPs why I almost took the site down. So hopefully you guys are feeling similar. So this is why I like running Aurora and Mesos, because we put a lot of this effort in, and even though it's a little bit more upfront cost, this means it saves us a ton of time and energy down the road. So here I'm going to dive into the setup of how we actually sort of put things together and make these pieces happen. So the first one is just a few notes about how each host is sort of provisioned. Then we'll talk about the build process that we use internally. And then after that, we'll go into the way that we actually deploy things. At any point during this, please reach out with questions. So yes, this is how the cloud happens, everybody. Absolutely. So thanks. So a few notes. The first one is we rely heavily upon C groups. This is actually what provides the resource isolation between user processes on the slave. And a wise man once said that good fences make good neighbors. And I think this is especially true when you have a multi-tenant environment. We rely upon our CPU isolation and our memory isolation pretty heavily. In fact, the reason that we're able to generate such good utilization in our clusters is because we sort of force these constraints upon all of our users. And so initially, when we were sort of capping people's CPU to only 8 processors or 4 processors, whatever they ask for, they'd say, hey, can I just spike up and use the extra 10 cores that are on the machine right now? Although, yes, that's nice, it turns out in practice what that leads to is sort of bursty behavior. And if for some reason they land on a machine where there isn't 10 CPUs available, then they won't be able to use that leniency anymore. So in this case, we're sort of trading the like the fortuitous like sort of luck for expected behavior. So I think this is something, if you're setting up a Mesos cluster and you're going to put it in production, you definitely want to make sure that you're using a new kernel. Any new distribution is going to have a kernel that supports this. In addition, you're going to want to make sure you're using something like Monet. I know some people are thinking about actually taking Thermos itself and using that to watch the slave as a replacement for Monet. I have not tried that in production, but I obviously do use Thermos in production, so that's an option if you're willing to put in the work and help make that a thing. But one of the other Mesos SREs, Toby Weingartner, he actually wrote a feature called Monet Gate. And essentially what that does is it's actually going to be a check which prevents Monet from auto-starting the slave unless we actually write to a file which is going to ensure that a few tests have been passed in some of our hosts. So what sort of would happen is our fleet management team would add a few machines to the cluster, and maybe they would have missed a few steps or there was a bug in their tooling, and when they did a handoff, it wasn't clean, and so they wouldn't have provisioned it correctly. And so on our end, we decided to be a little bit, add some safeguards, so we do our own set of checks and validation to make sure that the hosts are okay. So this is something that's definitely bit us a few times, is we want to make sure that each slave that's going to join the cluster isn't going to come up in some bad state. And even though we have a few checks in place, there's still a few that come through and a few edge cases. So this is definitely something that we're thinking about putting back into Mesos or some other function of gating these slaves before they enter the cluster. We do use Puppet to provision these hosts. So that is sort of the way that we make sure that we run these checks, all of the RPMs are installed. I know some people are using Ansible and sort of the like, the model of like Capistrano to provision machines or to make sure that they're running the versions of software that they expect. In practice, we found that that actually isn't quite as effective. We really want to make sure that we're pushing as much of the logic to the edges as possible. So we don't want to sort of have this like centralized understanding of what should your cluster look like, because if that ever goes down and a new slave joins the cluster, it may not actually be set up the correct way. Any questions so far? Cool. Lastly, when you do launch a task on your slaves, you're going to want to make sure that your user accounts are pre-populated. We have a cron, which actually is querying LDAP to make sure that the list of users is set up as expected. So that's sort of a gotcha that you may not know. A few last things. The default slave work directory is actually in /temp. So some people by default have like a temp watch or something. So you're actually going to blow away your entire slave configuration directory. Do not recommend doing that. That'll cause like a really bad situation like a week later when that runs across your cluster. So set that somewhere else, var temp, var lib, something like that. We also, as I said, we use Puppet. We distribute the configuration itself for Mesos via Puppet. Unfortunately, this does lead to some issues when we're actually trying to set certain attributes because some of them are actually used for scheduling, and the slave isn't able to cleanly restart and keep user tasks alive when we change those. So I think one of the big things that SRE is investigating is how do we actually make this a much easier process to get these configuration updates out to the cluster at once. Obviously, updating tens of thousands of machines to have a certain configuration is a sort of dicey proposition, so it's sort of like a long-term thought process. So if anybody else is working on this, we'd love to discuss this further on the list. Yeah, so the question was, why don't we drain the machines at the time? We'll get into the maintenance in a little bit, and that is actually what we do. But it's just that that is a little bit unwieldy for how quickly we'd like to move. Right now, sort of tying this configuration to making sure that we drain a batch size of hosts that's able to be taken out for maintenance is making our deploys very, very long to affect these large clusters that we have. So yes, that is exactly what we're doing, but I don't think it's where we want to be long term, unfortunately. Does that answer your question? Cool. Any other questions? Oh, interesting. The question is, do we allow slaves to join randomly, or is there set windows of time where they're allowed to be added? We actually do not gate based on time. So I think for us, for some reason, a couple rows of racks or something disconnected from the master, we wouldn't necessarily want to wait for a few hours from now for them to rejoin. So we don't necessarily worry about time. We sort of look for what is installed in this machine and is everything okay. So we have a different set of validation for that. Does that answer your question? Any other questions? Cool. So we're going to move on to the build. This is a topic that's near and dear to my heart. I don't know, I think it's the saying, keep your friends close, but your enemies closer. Unfortunately, we've actually had a lot of trouble keeping our builds easy, clean, and repeatable. I think a lot of the work that was mentioned earlier about moving to Mesos, which is a pure Python implementation, moving to maybe a pure Java implementation of the driver, removing the native code, I think is going to be a huge step for keeping the Aurora build simple. Fortunately for Mesos, we're able to use mock. We're building within Jenkins in CentOS. And so by using mock, we're actually able to remove all of the system dependencies and build up our build environment from scratch. It actually took a lot of work, and my teammate, Dave Robinson, actually put a ton of effort into that to make sure it worked well. And so I'm really glad that he did, because I was not interested in that. But we sort of have a very, we sort of have this like special set of scripts, essentially, which are sort of building each of these components for the Twitter environment. And so I think what we need to start doing now that we're able to actually build these reliably is start pushing these out into the open source. So if anybody is running into issues like we were, hopefully it's a little bit better now. I think some of this is starting to trickle out. But if you guys are still running into issues, please bring this up on the dev list, because we really need to make sure that we're, all of us SREs and DevOps are working together to make sure that when the developers are building the software, we're doing it in a way that isn't going to lead to extra overhead for the operators down the road. So essentially, I guess this drawing should make it a little bit clearer. So this is sort of actually the build pipeline that we have. So again, stop me any point here. So this is the Apache Git. So there are two repositories. There's the Aurora repository, and then there's the Mesos repository. But both of these sort of follow the same workflow, so I'm just going to combine them here. So we have an internal CI job, which we, within that CI job, we actually set an HTTP proxy, so we can go out and connect to the Apache Git. And what we're doing there is we're actually going to check and see what is the latest Git SHA that's on the open source repository. And does it match our internal fork, which we have within Twitter's Git repos. And so if this is different, then we're actually going to kick off, within this job, we're going to kick off a merge. And so this is going to run all of the tests, both internally and externally, make sure they all pass, and then try and do a merge. If it's all clean, then it'll automatically merge and then push to our internal repo. So the goal here is to make sure that our internal code is sort of following master as much as possible. My teammate Zeke has actually done a ton of work to get this up and running. So when I say this is how we do it. This is how we do it as of pretty recently, because previously we were part of our big mono repo. And so to make this process simpler, we've moved out to sort of follow this model a little bit more. So, yep.
What's in the internal fork?
So the internal fork, it contains a few components. I believe for the scheduler, it's mainly the authentication module and maybe one or two other common like internal modules we have, but essentially it's just our authentication. And for the Python components, I believe pretty much every Python piece has an internal entry point. So it's the Python binary for the Aurora client, for the executor, the observer, and we're actually using that to sort of put in a few internal pieces in there. So if you guys are familiar with clusters.py, these pieces are sort of where we plug in the clusters.py for all of these things. And a few other, we have our internal auth for the Python side as well. So I think the goal here is actually try to move as much of this internal code into a way that's much easier to maintain externally. So that way we decrease the amount of code that's only within Twitter and as much of it is external as possible. So it's taking a little bit of time, but that's definitely the goal with what we have. For instance, with the auth module, the work that Kevin Sweeney's doing for the Shiro integration, I think that'll help us remove the internal auth module, which would be great. Any other questions? Cool. So once we're here, we have our internal Git repo. It's synced with the latest master from the external, and it's got all of our internal code. Then we're actually going to tag the repository at whatever point in time we want to do a release. And we're going to push that into the Git repo. And when we're ready to build all of our components, we're actually going to kick off a Jenkins job. And so we're just using the Jenkins API to do this with a tool we wrote. But essentially, each of these components that we have here has its own Jenkins job, which is going to build each component based on this Git tag. So once we're here, the Aurora client, actually at the very bottom, you see this end-to-end tests. If you guys have seen the open source end-to-end tests, I highly encourage you to run them. They've saved us so many times. Before we had them, we would push out the Aurora client. Users would report bugs, and then we'd have to roll back, fix the bug, roll forward again, find another bug, roll back, and it just wasn't good. So now actually, instead of forcing our users to do our testing for us, we have these end-to-end tests which sort of execute the very common commands, which is actually pretty awesome. So the Git tag is actually something like Aurora client 43 or Thermos executor 27. So once we do this, the Jenkins job is actually just going to RPM build using a spec file we've defined. And inside of that, it's going to run all the tests and make sure that all the tests are green. And it's going to try and build an RPM. And then the Jenkins job will upload that into a Yum repository we have. So all of these pieces are built using, are built as RPMs. Yep. The CI jobs are not in a container, actually. We have our own Jenkins instance. There was a tech talk about this recently. I don't know too much about how all of our Jenkins is set up, but it is like a separate, it's not using Jenkins on Mesos, unfortunately. But I think our developer productivity team is sort of looking into how we can take advantage of that. We're managing dependencies, like in terms of like system dependencies, or? Well, you're building them from source, right? So yeah.
You need to then pull down the GC and all these kinds of dependency packages.
I see what you're saying. So the question is sort of how are we actually pulling down dependencies and how are we managing all that? So for Mesos, we're using mock to fully isolate the system and make sure that we're just building with a known set of components which are going to be used on our machines in production. With most of the Aurora components, we actually don't necessarily need to do that because the system packages that are installed on the Jenkins boxes are actually exactly the same packages that are in production for us. So we don't need to necessarily do anything within a container for that. Probably the best advice I could give is build on the same environment as you are going to deploy into production. If you can, even just build it in the same, like, if you have a Docker image, if you have some sort of standard image, try and build off of that as much as possible. Static link everything that you can. Because as much as possible, you want everything put into that PEX file or into that statically linked Mesos slave binary as possible. Once you sort of are dealing with these dynamic dependencies, you get into some trouble unless you're matching your environment. Was that sort of your question? Cool. Any other questions here? Mm-hmm. The client distributed. Oh, man. Okay. Okay, so all of these. Yeah, how is the client distributed? Oh, man. Yeah, nope. Okay, so, man, this is not good. All right. So the client, let me step back a little bit. So one great thing about pants and pecs is that we can actually build, sort of a executable Python binary, and it'll pull in distributions for both Linux and OS X at the same time. And so we actually have sort of like a DevPy server, essentially. So it's a mirror of Python distributions. And we actually upload all of our dependencies that are built on both OS X and on Linux. And so when we're building this Aurora client on Jenkins on Linux, we actually specify a platforms field in the build file, and we're telling it both Linux and OS X. So it's going to pull in dependencies for both platforms. All of the developer laptops here at Twitter are OS X, and so when they're running the Aurora client locally on their laptops, obviously if they get some Linux binary, it's not going to work. So to distribute that, we have sort of like a set of bastion hosts, and the RPM is installed there. And then actually my teammates Bill Farner and Kevin wrote something called .tools. It's not very fancy. It's basically just a rsync script, which is going to run via cron, and it's actually going to pull the Aurora client binary from the Nest machines, which are sort of our bastion hosts, and it's going to pull it down onto the laptop. It's not very fancy, but essentially every n hours, it's going to do this rsync, and if we've updated a new RPM, all of the laptops will get updated. So pretty sure that was correct. But yeah, teammates nodding right. All right. I'm sorry I had to divulge that. That's terrible. Any other questions on this stuff? Yep. Sure. So the question is sort of to go into a little bit more detail about how do we actually merge these changes from the open source repo, merge them in with a Twitter repo, and push that to our internal repository. Ideally, it's a clean merge and all the tests pass, in which case we're just going to assume that because nothing broke, we're just able to git push origin master. If there is a break, however, then that job is going to fail, and then it's going to send an email to the team, and then a human will need to go in and reconcile those differences. So in that case, they'll just sort of do this process, but do it manually, and then once they reconcile those changes, they can post that for code review internally, and then make sure that things look good, and then we can push that and move on from there. Does that answer your question? Cool. Any other questions? Sweet. So here's where, so I've spent actually a lot of time thinking about how do we do deployments. Initially, when I first started, we had tens of machines. Deployments were really easy, so I didn't really need to worry about it too much. But now that we've sort of grown and obviously tens of thousands of machines in one cluster, this is no longer a simple proposition, unfortunately. So for us, we're actually very fortunate that the team that maintains Puppet does a great job at making sure that that is scaling well and is able to handle all of the traffic that we're sending them. We're also leaning on this machine database, which is owned by another team, which is sort of tagging each host with a set of attributes. And I think one of the best things that we decided as a team was not to sort of build our own deployment solution, but to leverage what already existed and already was sort of tier -1. If these services aren't running, Kickstart doesn't work, new machines aren't provisioned. This is the sort of infrastructure that I think Aurora and Mesos need to rely upon. We didn't want to rely on something that we built and heaven forbid was running in Aurora or something, because then you sort of have this cyclical dependency problem. So for us, we actually, I think, again, my teammate Toby Weingartner sort of talked me off the edge a little bit when I was initially designing this, where I was going to build it using Ansible. And we do use Ansible for many different tasks, including deploying the scheduler itself. But when you have such a large fleet, I think that the pull-based model actually works really well for us. So in this case, we're actually relying on Puppet to look at a machine every time it comes up. It's going to look at the attributes that are stored within this machine database, and it's going to ensure that it has the right version of those RPMs. So we've written this tool, it's just called deploy.pex. We're not very flashy SRE team, unfortunately. And so you just pass it which cluster you're deploying to, how many of these machines do you actually want to affect. So in this case, we'd want to deploy to 5 because we have 25 hosts in our test cluster. And let's say we wanted the version 44 of the Thermos Executor RPM. So essentially what it's going to do is what this program is going to do, it's just going to send a few API calls to the machine database. It's going to figure out how many servers are there in this cluster. It's going to say, okay, well, I've got 25 of them. Let me just pick 5. And then it's going to tell the machine database, hey, update these 5 machines with version 44 of the RPM. So it's just going to put a little attribute on there. When these slaves are running Puppet, Puppet actually has a little attribute function that the team maintaining Puppet wrote, and that's actually going to query this database and look for that attribute to fill in the value within the manifest. And so as Puppet runs on these machines, it's going to look and say, oh, I should be running 44, but I'm only at 43, and then it'll update that. Yep. The machine database, yeah, what kind of database is the machine database? It's not, so it's an application that's fronted, so it's an application that's fronting a database, but I do not know what either of those are offhand. It's a Django app backed by MySQL. Teamwork, thank you. Yeah. Okay. Yeah. See, I know all these things, that's great. Okay. Other questions, did that answer? Cool. So yeah, this is awesome. I really wish we'd open source this. I'm sure that you guys know of something that's already open source that does something similar. I think this is a great, like a great tool in the toolbox to have for us. Mm-hmm. Totally. So the question is sort of, are you concerned about this database not being consistent? So why not use something like Zookeeper or Console? I think this next right key, if it works, is going to answer that. Yes. Okay. So we don't actually care about speed when we're doing deploys. Another one of our teams actually did build an agent which is looking inside of a Z node in Zookeeper, and as soon as that changes, all of their machines which have set a watch on this Z node are going to fire and execute, whatever, package fetch or whatever it is they need to do. So they can do their deploys really, really quickly, but unfortunately it really requires them to have Zookeeper up and running, and they sort of need to put a little bit of extra complexity in there to make sure that they're not overwhelming Zookeeper, and it was a lot of code to custom write. For us, because we don't have such strict requirements, like I'm totally fine with deployments taking hours and hours and days, because again, I'm not doing anything. It's just Puppet is running. Well, Puppet will run faster than that, but if it's, with all these machines that we're slowly rolling out to 5%, 10%, 20%. So for us, we're okay if, in this case, we have one machine which hasn't run for some reason. So for us, it's not quite, if a few machines haven't quite updated in a while for some, corrupt RPM database, something like that, if it becomes enough of a problem, we're actually going to be able to go in and look at what the issue is and fix that small issue. But for the most part, we don't necessarily care about that instant update. Does that answer your question? That's interesting. Yeah, so just to summarize, it sounds like, one more time, was the project name? Cluster? Clusto. I don't know why I can't remember it. I'm sorry. So Clusto sounds like you can sort of set like a canary set of servers, and those will run at the top of the hour to sort of pre-bake your changes and pull in whatever changes you need before the rest of the cluster would get these changes, essentially. Yeah, I think that for us that's worked out all right. We have had a few occasions where either the machine database is down, but for us that isn't really an issue. I could definitely see a case where we needed to roll something out very quickly, in which case an outage there would definitely delay our time to remediation. In practice, that hasn't been something that we're worried about, which is nice. And then obviously if there was some problem with how are we actually going to, if it's saying version 32, which was some old busted version, and all of a sudden all of these slaves are upgrading to an old version, yes, that would definitely be an issue as well. So in this case, we are definitely relying on the fact that this is a very well-maintained piece of software with a team that's been working on it for many years. And in fact, we actually felt like if we were to write our own agent using Zookeeper, we would have to solve the same problems this team did. So in that case, I think that was one of the trade-offs we made. Is yes, it's a little bit slower, and we're sort of putting our faith in this team's hands. But after talking with them, it seemed like the right choice. Do we run Hadoop and Storm on Mesos? We definitely run Storm on Mesos, and I think I'm not sure about Hadoop, but we're looking into it and working with the Hadoop community to figure out how to do that right. But we do not do any persistent storage in our shared cluster, unfortunately. So now we're kind of moving into operation. So sort of the things which I think, if a new SRE were to join my team, these are the things I would tell them about what it is to run and maintain an Aurora Mesos cluster. So the first one is just sort of some thoughts about how we do maintenance and what it is to have an SLA which we're held to by our users. The other is, again, like I said, a lot of the time we're spending so much working with other SREs for the teams that run services on top of Aurora. And then lastly, what are some good metrics which might be helpful, and what does it mean? So this is sort of a really quick crash course and stuff you may want to be aware of. One of the great things about Aurora is it's actually enabling us to move really, really quickly when we're performing maintenance. Because of how many machines we have, if we were to sort of follow the old model of, hey, let's get all of the service owners to acknowledge this ticket that we're trying to run this maintenance in, 3 weeks, and they all need to approve by this date, otherwise the maintenance gets pushed back. If we still were trying to do that, there's no way our network engineering team would ever be able to fix a broken rack switch or anything like that. So in this case, the host maintenance API is really critical because it enables us to make sure that we're not taking a service below SLA, but still able to do our operations in an automated way and not actually put some SRE behind the keyboards this entire time. This is also awesome because then users get a message which is saying why their task was rescheduled. They'll see it was killed for maintenance. And I think this is something that's really been helpful because it helps all of our users understand, hey, was there something in the data center? Was there a bug? Did this task go lost? Was it failed because we had some problem with our application? Or hey, this was killed because Joe was, needed to reboot this thing or some other reason. And one of the things which, kind of like a small anecdote, I guess, when we were rolling out our network monitoring to enable that within the Mesos slave, we had so many machines getting added in here, which we had to deploy, which is almost complete. So we had 90% of machines had this network monitoring enabled. After, I think it was 1 week, or maybe it was Thursday, it was 90%, great success. And then it was that Tuesday or something, it looked like we had gone backwards in time, and we only had 75% of the machines had network monitoring enabled. And that was just because of how many machines had been added to the cluster, which again, if we didn't have something like Aurora and Mesos, we would not have been able to absorb that growth that quickly. What's great is, I didn't even notice. I just was like, oh, okay, cool, and I just kept running my tool and just kept upgrading boxes, and I was writing unit tests in the background because we all love tests, right, guys? So yeah, so that was great. Questions about this stuff here? Cool. So I think once, if the people in this room, if you are going to be the ones that are running Aurora and Mesos, you will quickly become the experts within your company, within whatever operation team you're part of, and application developers are going to have lots and lots of questions. I'm sure many of the questions that you guys are going to have now, and that's why it's really important that every time you find something missing in the docs, or if there's some gap in the guide or something like that, let us know in IRC, send an email to the list, send in a pull request, or I guess it's a review, an Apache review board. Let's get that updated and make sure that that's up to date, because as the operators, we're sometimes that sort of front line of defense for the other operators in the company. How do we do this? Hey, we need to do this deploy really quickly, and we're not getting the metrics that we expect to see. Our CPU is being throttled with this application. What does this mean? So this is really important. That said, don't be too helpful. It's really easy to sort of get burdened by user support, especially when you're running this huge platform, which is running the rest of engineering's services. So you'll get a ton of requests, things like, oh, hey, can we just install this RPM for Python requests on every machine in the data center? as much as possible, push back on requests like that. The last thing you sort of want to do is continue to pollute the image that each slave is running under. I think this is something that Steve mentioned as well. I think for the most part we were pretty good, but we have a few pieces which I think kind of snuck in, a few moments of weakness on my part. So definitely the less that you sort of bring along, the much easier it'll be, because then you don't need to worry about version incompatibilities, things like that, which is nice. And again, application developers are going to give you great feedback. So one of the big things that we did was we parallelized the updater within the Aurora client, and this was one of the big feature requests that the users and the engineers within Twitter really asked of us. So I'm sure that as you guys get more users, you're going to get similar requests for features and functionality. So definitely bring that to the Aurora community, and we can work on getting that prioritized, and either help you guys get that fixed or see if we can get that built out as well. So questions about this stuff? Working with. So these are a few of the interesting metrics that have come in handy and scared a lot of us over the years. This one is about Aurora here. One of my least favorite ones is when scheduler resource offers goes to 0. Man, if this ever goes to 0 for you, I am with you. I've been there. It's terrible. This means that the master is not giving any resources to Aurora. So this could be for one of any number of reasons. Maybe the scheduler and the master aren't communicating. Maybe all of your slaves just went down. This could be any one of several terrible things. So you sort of need to look at the other metrics to figure out what the actual issue is. But definitely setting up alerting on this is very critical. Another one is just the JVM uptime seconds for your scheduler machines. This one's hopefully pretty self-explanatory. How long has the scheduler process been up and running? Framework registered means that Aurora is actually registered with the master. So once this happens, you have, you're most of the way there to a good, well-running cluster for the most part. Another piece, which is actually on the Thermos Observer, which I know we're talking on the dev list about deprecating. But this one's actually really helpful. This is actually how to track service discovery across your cluster. So users can actually include an announcer within their job config. And if they do that, that'll actually help announce to a zookeeper that you've defined. This is actually really great, and it sort of centralizes the zookeeper clients, so you don't have tons of custom clients, which we'll get into in a little bit. And lastly, just having a test job which you run, and just make sure that you're tracking how many instances are up and running. This has been a great signal for us. We have a job called LabRat, and LabRat's job is just to run out in the cluster and stay alive. So it's been pretty handy. Questions about Aurora Metrics? This is just very high level, unfortunately. This is some of the Mesos metrics, which are really critical. The number of active slaves in your cluster, according to the master, this is obviously if it goes to 0 or dips below what you'd expect, something's wrong with the slaves. Is there an elected master? So, not having an elected master means you're not making progress and keeping updates with your system, essentially. Taking a look at the event queue, if this is starting to increase and grow without bound, this usually means that there's some problem where the master isn't able to process messages from the slaves and from the frameworks. So this is usually a sign of something really bad happening. Uptime is very similar, and number of lost tasks in your cluster. This is also very useful to see if maybe you have a power event or you're losing rows of racks or something like that. So this is the master is just losing track of all of these tasks. They could still be running, but the master doesn't know about them. Questions about the master? Cool. So just wanted to go into some of the incidents and issues we've had. We've had a lot of different issues related to the Aurora client. So this is actually the piece that most of the users actually are interacting with every day. Unfortunately, because of this, they put it through its paces. There's so many bugs, which I didn't even think were possible, that users have found, as they always will. I think we've gotten into a really good state here, especially compared to even where we were maybe 6 months ago. So I'm really looking forward to even more of the improvements coming up. Just if we have time, hopefully talking about Zookeeper and then some of the health checks we have as well. So this is when the cloud isn't good, unfortunately. So I think one of the big issues we had is just making sure that we're batching these commands that we're using. Sometimes we would have these huge operations which would perform all at once on a certain job. So for instance, if we had a really critical user job which somebody had accidentally run Aurora kill, this was maybe about a year ago, it would actually wipe out every instance of that job. So all of a sudden, this entire service, which was happily serving traffic and doing its thing, if they typoed and they didn't include -- shards equals 2, instead of just killing one shard, it would kill hundreds or thousands of those, unfortunately. Another improvement is we're actually just using Aurora Client version 2. I hate the V2 syndrome, so I think we kind of made a mistake there. But it actually is much more reliable now, and by removing the version 1, it's much simpler, which is great. In addition, we also put a little bit of time into simplifying and improving the validation between the update config and the health check configuration. Initially, there was a period of time where somebody could set their update configuration to be smaller than their health check. And so actually, my teammate Maxim worked on this, but basically what this would happen is the Aurora client would just perform an update and it'd say, oh yeah, everything's probably fine, but the health check hadn't even kicked in yet. And so the client would just continue updating things. Meanwhile, all of these instances would start failing and success rate would go down. So, so this was something we had to figure out and make sure that we had a good way of communicating this to users and improving this within the client. And then of course, every time there's an improvement to PEX, I get very excited. Tons of improvements to how we're like scrubbing syspath and putting more isolation in here, which is great. Questions about like the client? Cool. So one thing about Zookeeper, it's great. It's sort of the like tier negative or tier like 0.5 or well, I guess tier negative 0.5 service. Everything sort of relies on it. One of the things that we discovered was we probably should not be using the same ensemble that we're using for service discovery as for leadership election for infrastructure services. So this for us was actually a really terrible death spiral. We had a few misbehaving clients which were increasing latency on the Zookeeper ensemble, and they were behaving in such a way that they would actually cause some other clients to disconnect, and when they reconnected, they actually hadn't lost their ephemeral Z node when they were registering themselves, but they thought they had, and so they would re-register another one, and this would increase latency even further, and so more instances would drop out and then re-register again. This actually caused the Aurora scheduler to lose its leadership because it timed out its session, and so it had a connection loss. And so Aurora couldn't get elected, but services were continuing to sort of flap and increase latency, but we couldn't restart these services because Aurora was down. So it was sort of a really terrible situation for a while. We were able to sort of remediate this issue by sort of going out of band and fixing some of these instances and restarting them, and then that gave us enough room to keep Aurora up long enough to actually restart the misbehaving services, which was nice. But yeah, definitely, if you are running on the same ensemble, put in the time and effort now to switch them apart because you will probably get there shortly. Just the very last message, I just wanted to talk about I think we're still working on improving the way that we do health check for instances. Right now it's 100% user controlled and user defined. I think we can do a lot better job, even just internally within Twitter, and I assume you as operators with your teammates, explaining to people how do we actually set this health check and how do we do it in a way where if you do get a ton of traffic and maybe go into some GC spiral, we prevent the entire service from being killed all at once. Unfortunately, what this means here is that if you're killing everything because they're taking too much traffic, and then as soon as one instance gets rescheduled, it's going to receive a ton of traffic to just that one instance, and then of course it's also going to die. So you sort of run into the situation where a service can never get started up again, unfortunately. So this is sort of Aurora 279 is, I think, a little bit of a ways out still. We still need to figure out how do we actually consolidate this and put some smart logic in some place without creating a huge single point of failure, but also making sure that services understand what is good health check behavior and what does it mean for their service, as well as how do we improve load balancing on the clients. So I think that's it for us. You guys probably all know this stuff, so I think I'm done. So thanks.